Today we are going to be talking about the value of trig functions. By the end of this video, you should be able to review all unit circle values, and you should be able to find the trig values for non-special angles. In this video, I'm assuming that you are already familiar with the unit circle and that you easily remember the values for sine, cosine, and tangent of angles that are on the unit circle. Our first problem says find the exact values of sine of pi and cosecant of pi. So if we think about the unit circle, the angle pi is here. Sine is the y value of that point, which is 0. So sine of pi is 0. Cosecant is 1 over sine. So cosecant of pi is 1 over sine of pi, which would be 1 divided by 0, which is undefined. If we want to find the cosine of 60 degrees, is here. Cosine is the x value of that point. If you remember from the unit circle, that point is 1/2 square root of 3 over 2. So cosine of 60 degrees is 1/2. Since we know that secant of 60 degrees is 1 over cosine of 60 degrees, then we have 1 over 1/2, which is 2. Here we are looking at the angle 5 pi over 6. 5 pi over 6 is here on the unit circle, and this point is negative square root of 3 over 2, 1/2. So sine of 5 pi over 6 is the y value, which is 1/2. Cosine of 5 pi over 6 is the x value, which is negative square root of 3 over 2. And tangent is y divided by x, or sine divided by cosine. So we have sine of 5 pi over 6 over cosine of 5 pi over 6, which gives us 1/2 divided by negative square root of 3 over 2, or 1/2 times negative 2 over square root of 3, which gives us negative 1 over square root of 3. And then if we rationalize the denominator, we have negative square root of 3 over 3. Next, we have tangent of negative 11 pi over 4. Well, that is not an angle that's on the unit circle. So let's look at a coterminal angle. If we have negative 11 pi over 4 plus 8 pi over 4, we get negative 3 pi over 4. And then if we add 8 pi over 4 again, we get 5 pi over 4, which is on the unit circle. 5 pi over 4 is here. The coordinate is negative square root of 2 over 2, negative square root of 2 over 2. Tangent is y divided by x. So the tangent of negative 11 pi over 4 is 1. Finally, we have cosecant of 29 pi over 3. Again, we need to look at the coterminal angles. So if I subtract 6 pi over 3, I get 23 pi over 3. So I need to subtract again. That gives me 17 pi over 3. Subtract again. I get 11 pi over 3. Subtract again. And I get 5 pi over 3. So I finally get a value that is on the unit circle. 5 pi over 3 is here. Coordinate is 1/2 negative square root of 3 over 2. We know that cosecant is 1 over sine, so I have 1 over sine of 5 pi over 3. Sine is the y value, so I have 1 over negative square root of 3 over 2, which gives me negative 2 over square root of 3. I need to rationalize the denominator, so I get negative 2 square root of 3 over 3 as my final answer. So make sure that you use coterminal angles. If you're given an angle that is not on the unit circle, hopefully you will end up with an angle that is on the unit circle, and then you can calculate the value that you're trying to find. Here we are told that sine of theta is 4 over 5. The angle is in quadrant 1, and we need to find the other 5 trig values. So let's start by sketching a picture. We know that our angle is in quadrant 1. We know that sine is 4 over 5. We also know from geometry that sine is opposite over hypotenuse. So this tells us the opposite side is 4, the hypotenuse is 5. We can then use the Pythagorean theorem to find the missing side. So I have 5 squared equals 4 squared plus, I'm going to call this x squared. So 25 equals 16 plus x squared. X squared is 9, so x is 3. Because we're talking about side lengths of a triangle, we know that the square root of 9 is not going to be negative 3 in this situation. Now that we have our triangle, we can go ahead and write out all of the trig functions. So we are given sine of theta in the problem, which is 4 over 5. Now that we have this triangle, we can find cosine of theta, which is adjacent over hypotenuse, so 3 over 5. We know that tangent is opposite over adjacent, which gives us 4/3. Now, I purposely wrote cosecant of theta next to sine of theta, secant of theta next to cosine of theta, and cotangent of theta next to tangent of theta. That way they are paired up with their reciprocal functions. Now, to find the last 3 trig functions, all I have to do is take the reciprocal of the values we've already found. So cosecant of theta is 5 over 4, secant of theta is 5 over 3, and cotangent of theta is 3 over 4. For this last problem, we're told that the terminal side of beta contains the point 8, negative 15, and we want to find all 6 trig functions for beta. So let's start by drawing a picture. The point 8, negative 15 is in quadrant 4. This is angle beta. We know that the sides of the triangle are 8 and negative 15. We can then use the Pythagorean theorem to find the radius. So we have that 289 is r squared, so r equals 17. Now we can find all 6 trig functions. Sine of beta is opposite over hypotenuse, which is negative 15 over 17. Cosine of beta is adjacent over hypotenuse, so 8 over 17. Tangent of beta is negative 15 over 8. Then cosecant, secant, and cotangent are just the reciprocal of the first three functions. So we have all 6 trig functions. Just as a little hint, in the first quadrant, all of the trig functions have positive values. In the second quadrant, sine is the only function with a positive value. Both cosine and tangent are negative. In the third quadrant, tangent is the only one that is positive. Sine and cosine are both negative. And in the fourth quadrant, cosine is the only function that is positive. Both sine and tangent are negative. Obviously, the reciprocal functions have the same sign as the original functions.